In the previous section, we covered why machine learning is the future with some great examples and case studies. We also covered what is machine learning, its definition, as well as how machine learns along with supervised and unsupervised learning. We also covered different data types, categories of data, along with the common machine learning terms such as mean, median, mode, range, etc. We briefly touched upon different types of machine learning models which are available. Now, in this section, we will cover what is Microsoft Azure ML along with an overview of the Azure ML Studio. We will along with cover what is Microsoft Azure ML along with an overview of the Azure ML Studio. Microsoft Azure ML along with an overview of the Azure ML Studio. We will also create your free account on Azure ML and then walk you through the various modules and sections within the studio. Every machine learning algorithm implementation follows a set workflow, and we will cover that in the context of Azure ML. Last but definitely not the least is the Azure ML cheat sheet. Azure Machine Learning Studio has a large library of algorithms from regression, classification, clustering, as well as anomaly detection, and each is designed to address a different type of machine learning problem. The ML algorithm cheat sheet provided by Microsoft helps you choose the right algorithm for a predictive analytics model. So there is a great deal of topics to be covered, and I'm so excited to get you started on your ML journey by creating a free account for Azure Machine Learning. Thank you so much for joining me in this one. I'll see you in the next class. Until then, have a great time. Hello and welcome. In this lecture, we are going to learn about what is Microsoft Azure ML. As you may be aware, Azure is the cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services. Azure Machine Learning is a fully managed cloud service to build, deploy, and share the predictive analytics solution. It provides tools such as Azure ML Studio to create complete machine learning solutions in the cloud. One of the main differentiators of Azure ML is quick model creation as well as very quick deployment using Azure ML Studio without writing a single line of code for basic ML experiments. Secondly, though one can build various models, it requires some efforts to deploy them as a web service so that other developers within your project or outside users can also use it. Azure ML solves that problem very efficiently and allows models to be deployed as web services almost instantly. Any machine learning library finds its strength in the pre-built modules and algorithms. Azure ML scores heavily here as well against some of the other such service providers and comes with a large library of pre-built machine learning algorithms and modules. And if you are a data science developer and has pre-built models, Azure ML will work for you as well. It allows the developers to extend the models with custom-built R and Python code. Let's try to understand the Azure ML with an architectural overview. Azure Cloud is where you will be able to create and store all your projects, experiments, models, and datasets. These can be accessed from anywhere and at any time. All you need is an internet connection and a laptop computer. With that set up, we can now access and process the data on Azure, can also do feature engineering, and build and test our models as well as deploy them. We can also transfer the data in and out of Azure as required. Various data transfer protocols and means are supported by Azure, such as HTTP, Hive, Azure SQL DB, any on-premise data that you may have, and various other forms of storage on Azure, such as DocumentDB or blob storage as well. All the models that we will build can also be consumed using a simple web service from anywhere in the world. This will help you deploy and test your models in the real world, as well as even sell your ML models as a service. That is why Azure ML is considered to be a game changer in the cloud-based machine learning services. That brings us to the end of this short lecture on what is Azure ML. Hope you have enjoyed this session, and I'll see you in the next class. Until then, enjoy your time. Hello and welcome to the Azure Machine Learning course. We are now only few steps away from creating our machine learning model in Azure. But these are very important steps. Today, we are going to talk about the workflow of Azure Machine Learning experiment. You may want to pause the video and get yourself a cup of coffee before we proceed. All right. It typically follows a 5-step workflow. First one, get the data, prepare the data, feature selection, choose and apply learning algorithm, and finally train and evaluate the model. Let's go through them in slightly more detail. Remember, we are going to have separate sessions on data transformation as well as for individual algorithms. I usually prefer explaining some of the complex principles while doing the hands-on labs. In this lecture, we will simply learn about various steps. All right, let's look at the get the data step. This simply means making the raw data available for the experiment. This is logically the first step for any machine learning experiment, and Azure ML is no different. Azure ML provides multiple options for making the data available for the experiment. You can use the enter data manually module to create a small single column dataset by typing values rather than loading the data from a source in Azure Machine Learning Studio or from a local file. In case you're wondering why would you want to insert the data manually, well, it can actually be helpful in certain scenarios, such as generating a very short list of values for testing or typing a list of columns to insert in a dataset. All right. Another method using which the data can be loaded is import data. You can use the import data module to load the data into an experiment from existing cloud data services that are outside of Azure Machine Learning Studio. The module now features a wizard which makes it so much easier to help you choose a storage option and select from among existing subscriptions as well as accounts to quickly configure all the options. The wizard can also load your previous configuration details so that you don't have to start again from the scratch. Another method to make the data available is by using the module unpack zipped dataset. You can use unpack zip dataset module to get compressed data files and unzip them for use in an experiment. The module takes a dataset as input in your workspace. You need to upload that dataset in a compressed format and then decompresses the dataset and adds the data to your workspace. This is particularly useful because you can reduce the data transfer time when working with very large datasets by saving and uploading your data files in a compressed format. All right. The next step in the Azure ML experiment workflow is preparing the data for the algorithm. Azure ML provides various modules to prepare and transform the data. You can apply various filters. You can also manipulate the data either by adding rows or columns to the data or by cleaning missing data values or even editing the metadata, such as changing the variable type from non-defined to categorical or from numeric to categorical and vice versa. For any dataset available for experimentation, we want to split it into training set and test set. Azure ML achieves it by providing a split module. Now that the data has been loaded and it has been processed also, the next logical step in the Azure ML experiment workflow is to select the features for our experiment. Azure ML provides a variety of ways such as filter-based selection, feature LDA, as well as permutation feature importance. Now within the filter-based feature selection, it does provide us a variety of options such as Pearson correlation, chi-squared, and so on. The next step in the experiment workflow is to choose and apply the algorithm. Azure ML provides a vast array of algorithms that we can apply. It also provides a range of parameters that can be tweaked to get better results. Last but not the least is training and evaluating the model. Again, there are modules for training, scoring, and evaluating the experiment and the model that you have built. All we need to do is provide the appropriate input and output connections. That brings us to the end of the lecture on workflow of Azure ML experiment. To summarize what we just discussed, there are 5 steps in the Azure ML experiment creation. First one is to get the data to Azure using various input modules, preparing the data using a collection of data transformation modules, selecting the features for the experiment, choosing and applying the algorithm based on a criteria and from the list that has been provided. Finally, training and evaluating the model, where we evaluate the accuracy and few other parameters of the model. Please remember that any machine learning experiment can be implemented by following these 5 steps. All right. In the next lecture, we will try to understand which algorithm to use in which condition by considering the Azure ML cheat sheet. Until then, enjoy your time and thank you so much for joining in this one. Hello and welcome to the last lecture of this section of Getting Started with Azure ML. In the previous lectures, we learned about what is Microsoft Azure ML. We created a free account for ML Studio and now we are familiar with Azure ML Studio. One of the important lectures to get us started was workflow of Azure ML experiment, in which we understood the steps needed from getting the data to evaluating the model. In this lecture, we will cover very briefly the Azure ML cheat sheet. I strongly recommend that you download the one from the course content or by searching for Microsoft Azure ML cheat sheet, which will straight away take you to the link from where you can download it. You can pause this video while you download it. All right. So this is how it looks, and first time when I saw it, I was completely overwhelmed. It is indeed very intimidating as well. Do not worry though, as I have broken it down further for easy understanding. The goal of Microsoft in providing this cheat sheet is considering a specific set of audience, which is a beginner data scientist with undergraduate level machine learning knowledge who is trying to choose an algorithm to start with. That also means that it makes some generalizations and oversimplification, but it more or less points you in the safe direction. All of these recommendations are a rule of thumb and should not be taken as exact. At a higher level, it boils down to what is the outcome or type of prediction we are trying to make. If we are predicting categories, we would use classification. However, when the outcome that we want to predict is binary, such as yes or no, pass or fail, success or failure, that is, if the outcome can only have one of the two values, we would use two-class classification. If the outcome is of multiple category, then we use multi-class classification algorithm. All right. Next one is if the value that we are predicting is a continuous variable, then we use regression algorithm. Sometimes the goal is to identify data points which does not fit the usual path or are considered as outliers, such as trying to identify the fraudulent transaction. Then we use anomaly detection algorithms. And when our goal is to find out patterns in the dataset and we do not know the dependent variable, we would use clustering algorithms. Simply adding our problem statement to these four buckets is not sufficient. There are several other algorithms and all of them perform with varying degrees in different circumstances. Their characteristics are also very different. Hence, we have to consider some additional parameters so that we can choose correct algorithm beyond classification, regression, clustering, and anomaly detection. Let's go through them one by one. Those are accuracy. Sometimes you do not need an exact or very accurate answer. It may even result in overfitting. An approximation sometimes could be sufficient, as higher accuracy could require more iterations and hence more computing resources. The next one is training time. Similarly, depending upon the algorithm we use, the training time could also be different. This is also one of the points to be considered if training time is a limitation. Number of features or independent variables could also limit the ability of an algorithm to provide faster results and hence an important criteria for selection of algorithm. The next one is number of parameters. As we will see when we build the models, every algorithm requires a certain set of input parameters for it to provide desired results. Large number of parameters could also affect the training time and accuracy. Another factor is the linearity. Many machine learning algorithms make use of linear assumptions. In the first two examples, a linear algorithm might work best. However, in this particular example, a linear algorithm might just not provide the correct results. Hence, it is very important to visualize the data and understand linearity of the data before we choose an algorithm. That brings us to the end of this lecture on Azure ML cheat sheet. I suggest you keep it handy all the time whenever you are working on machine learning models. It guides you in the right direction. Thank you so much for joining me in this one, and I will see you in the next class. Until then, enjoy your time.